Good morning. It's great to be here. It's great to be here because every year we get to come here and you're kind enough to let us show our progress. So my name is Tudor Girba. I'm come from Think, a company that I co-founded. And the goal of Think is to explain other people's systems. That is, we go into systems that other people might be afraid of, and we put a view on that system in a way that makes other humans understand it. Because we think that systems, any software system, should be explainable. And we capture everything we believe in one environment that is called Glamorous Toolkit. Any of you heard of Glamorous Toolkit before? Who didn't hear of it? Wow, okay. So last year we announced the alpha version of Glamorous Toolkit, and this year we are announcing the beta version of it. And now, what exactly is Glamorous Toolkit? So, Glamorous Toolkit is a development environment, but it's not any kind of development environment. It's something that we call a moldable development environment. So, how does that one look like? So, these are the components that are in the environment, right? So we could start talking about different features that are in there, but we really think that that's not exactly the right way to look at such an environment. Instead, we want to look at it as the kinds of things that you can do with it. We look at it from the experience that you as a developer might have when you actually work with your system. Because we really want to turn this idea that systems are or people are afraid of systems into a situation where people love working with their own systems. So it is really the experience that we are focused on. So from that perspective, right, we started from this idea of creating a moldable development environment. And that one looks like this. So if we look at a classic problem, that is that of inspecting objects. Right, so here, for example, I have 6 different objects. And if I look at them from afar, they all look the same. Right, I get a generic presentation, which basically shows me variables, and it shows me values of those variables, but they all really look the same. There's no difference between them. And so now I have to apply my mind, and I have to really think hard. What is the difference between this? Are they really the same? Are they really different? So I can see, for example, that one object over here has more state or more variables than the other ones, but that's pretty much it. But if I take exactly the same object and I showed you like this, then all of a sudden your brain, in seconds, infers information that is otherwise very difficult to infer. Right? It's very, very costly. And all of a sudden your attention, your energy can actually be focused on what you want to do and what you want to accomplish. And this completely changes the experience. And that's what moldability means. And so we go from here, right? So here we say, this is a simple number, like the one on top. It's a simple number that is a fraction, and then why not show it as a fraction? There on the right, we see a folder, there's a picture. This is a Bezier curve. This is actually depicting an algorithm, a step in an algorithm that we use for creating a nested circular tree map. And there on the right is a data structure in the text editor that helps us make the text editor fast. So it's a rope data structure. So you can see how we can have a very wide variety of different kinds of objects, and they can all look different. And we really believe that everything about software is highly contextual, and as a consequence, it has to look different, because that's how we are wired. And we should design the experience in a way that is comfortable for humans. So how do we go from here to actually building an environment? Well, basically we do it like this. So this is how the inspector looks like. Now, oops, how do we turn this on? How do I? It's not moldable enough. Okay. So, yeah. So what's interesting about this is that actually this is a whole environment, right? This is an actual inspector, and every one of those inspectors, they have different presentations. So every one of those objects can be actually looked in a different way. So we showed this concept many times before, and now we think that we have a very a solid presentation of that and a solid incarnation of that concept. But today I want to show you the differences. So what is next? What comes after that? What comes after just the inspection? Now, when we started to work on Glamorous Toolkit, about 5 years ago, we announced the idea that we want to focus on a new, completely different kind of a development experience. When we have done that, we started from the inspector, and we stayed with the inspector for a very long time because we thought that that's the one core experience. If you can change the core, if you can change the smallest unit, then you have a very deep or have a very high chance of changing the big patterns. So this is why we spent a long time on the inspector. But of course, not everything is about how you inspect objects, but it's also about how you code. So I want to give you a brief idea of how the environment looks like today, but in terms of coding. So again, just like how we started with the inspector from the smallest unit, when we talk about coding is either a method or a script. So that's basically it. So we started from exactly that. So here we have a method, and that method is encapsulated in a little piece. And it's editable by itself, and you can put it anywhere else, right? We call this one a snippet. And what's interesting about this is called this is the print string method in class object. And what's interesting about this is that besides the fact that you can edit things, let's say if I do this, as I type, some things appear here. So that's a triangle. And that triangle allows us to expand that method, because now I know what that method is. It means that I can go in and expand that. So that's quite interesting, because now there are all sorts of things that we can see in literature and various conversations, for example, about the size of a method. And people say, well, in Smalltalk, everything happens somewhere else, and the navigation is very hard. And so just because making the method small, there's a trade-off between making methods small and having code to be readable very quickly, or being able to get a glance over a large piece of logic. And we think that should not be a choice, right? And that choice should not just be limited to what you can do with just a single plain editor. So this is a simple solution that basically does away with a large or a conversation that actually takes a significant attention. So this is the idea. That the idea here is we think that there's a whole lot of things that we can rethink in the development environment just because nobody has done it before. We didn't really spend systematic attention on how to evolve our environment beyond the things that we have created a significant amount of time ago. And I'm not just talking about the Smalltalk environments, I'm talking about any kind of environments. So many of those have not really evolved significantly over the last decade or so. So what can we do with this? So one option is, obviously, we need to go and navigate or browse a whole class, for example. So in this case, I'm looking at the baseline of Glamorous Toolkit. Now, as I said, it's important to see how this idea of moldability applies throughout the whole environment. So we saw how moldability applies to different objects so that we can present different views. But the same thing applies through a whole range of different situations. It applies to the way we code, it applies to the way we debug, it applies to the way we search. So here, for example, we have a method or a few methods, and those methods, they are presented to us in a list. And so we can go and expand each of those methods. We want multiple of them at a time if you want to. and obviously go and edit there. And then the actions are presented nearby all the time. So in the baseline, right? Any of you have worked with Metacello before, right? Now Metacello is this really nice, exciting project that Dale created a long time ago. And we are all using them, especially when we're working with Faro or Gemstone. And so that's the configuration tool. So this is where we define how a project looks like, the dependencies to other projects. Now what's nice about it, it comes with the DSL, right? So we see here, okay, a spec, we have a baseline. So in Glamorous Toolkit, we have a baseline, and we're gonna load clipboard and documenter and presenter and so on. Now, whenever you're working with strings, that can be problematic because, strings can support anything. Now, what's interesting about this is that there is this little triangle next to the string. Because again, because we know that we are in a baseline, and that baseline has a method called baseline that is annotated with this annotation. And we know that the argument that gets there is a spec, and that spec has a baseline method. And there's an argument there, and that is supposed to actually point to another baseline. And if that baseline does exist, I should be able to show you that baseline. Again, there is no need to make that trade-off. Very often we found ourselves creating a baseline, committing it there, trying to load it up, and then 5 minutes later figuring out, oh, we have misspelled a string. There is no need for that. There is much better use for the human brain. So that's the idea. The idea here is, again, like here we're nesting things not based on self-calls, but we're doing them based on highly contextual, library-specific dependencies, right? And this is what informs the navigation. So now the cost of creating this is actually as small as with creating extensions to the inspector. So it's literally maybe a dozen lines of code. And that's it. Now, but it can go a little farther than that. So for example, here we see, well, clipboard, right? So if I delete this, the editor live just recognizes that there is no such project. But if I type here, right, then there is completion, obviously, because completion is the other tool, right? So if I can analyze if a certain dependency exists, I can also utilize the same logic to propose completion there. And as I type there, the triangle appears and I can continue working. And that's quite interesting. And again, the same thing applies to packages. So here we have packages, and if we want completion for the package, then we can simply have it there. So that's a different take on how possibly the experience of working with CAM can look like. So we have these units, these snippets, and then we can start combining them, right? Because the code doesn't have to appear always in the same place. This is a very interesting thing. If you think about it, it's very, very often, right? In a typical Smalltalk environment, you're editing the code exactly at most in two places. In the class browser, and you're always seeing the same thing, or a system browser, or in the debugger. But that's it, right? And there is no need, or there is no reason for code to exist only in those places. It can exist in a variety of different places. And then again, it changes the experience. So if we look at this, right, another place where code becomes interesting is when we are searching for things. So let's say here, the way we extend the inspector is through a method that we put in the class of the object that we want to inspect, and we annotate that method with a pragma, which is called GTView. So now if we have that pragma, then we can actually look for all that name, we can actually look for all the pragmas there. So once I get this and I inspect, I get a filter there. I get all the things that are annotated like that. And as I go, I get the inline editor right where it is, right? So it's we're kind of like in the references situation, but I'm actually just looking for the things and I can go and edit it right in place. And I have syntax highlighting too. So what's interesting about this is that syntax highlighting is not text-based, but it's AST-based. So it will actually highlight exactly the kinds of things that you're interested in. And now the other thing that is also interesting here is that we can go and say, well, maybe I'm just interested in those extensions that are in the package called inspector. And if I say GT packages matches, I will get only those that exist in those classes. Okay, so let's go quickly back here. So if I look at this, all the pragmas for GTView, right? Oops. If I go and I look at all the pragmas for GTView, I see here the list of results, but I can also see a couple of metrics. So in this particular image, I have 720 such extensions, 720 different plugins that coexist in parallel, and they add value because somebody created them, right? The other interesting thing to notice here is really this one over here. So maybe if you don't see it, this is the lines per method of each of these extensions, and that's literally 11 lines of code. And that's interesting because what this means is literally we can go and extend our environment in minutes. And we can do it live, because another place where methods become interesting are in the meta tool. So here we have a whole coder embedded into the meta tab for the object that we're playing with. And again, we have the same kind of an experience there. Okay, so that's basically what we have about coding. And so we started from this idea of what is the unit, and then we started to compose that in different ways. So we started to compose it for how we write code, so in the coder, but we also started, you notice here that we have different snippets, and so we can go and write some more code over there. So again, the same idea of snippets is reusable. And then in the search, and the search is composable, and then we can play with this further. So for example, if I go here and I look for implementer of next all, I actually get all the implementers of next all, and that's another search. And that search can easily be extended here. So I can say we just want it for something that calls GT class matches. So basically, I just look for implementers, and I am now limiting the scope of the search to just the classes that start with GT, right? So again, there is no end. There is no end where there's no place where coding stops to be available. Coding is always available because that's what it means to be in a live environment. There's no reason to just capture the developer into a clicking interface. Because one of the things that we realize is that the developers are not clickers, they are programmers. And so we should design it in such a way that we can hone exactly, we can utilize exactly the abilities that they have in order to accomplish the kinds of things they want to do. So that's a little bit about how we can code. Now, of course, the same snippets apply to the way we debug, right? So the debugger is exactly in the same way. So here I have a stack, and I can see that I have different, I can see the whole trace at once if I want to. But one of the things that I want to show you here is that this is an actual example. You might remember that examples are a different way to look at objects and compose tests. So rather, it's basically an example is like a test that returns an object, and all of a sudden it lends itself to all sorts of interesting properties. One of the things here is we are just open a debugger on such an example, and so every time we look and we go through a test, sometimes it's interesting to see the preview of the variable. So if I now toggle that preview, right, and I start just to go over that, right, I can see that a rope is nil here when it does a self small, and all of a sudden the rope is called hello. So if I zoom here in, right, you can see the name of it. And again, if I go over there, I can see that from that hello, I will delete from 1 to 3. And as I go there, I can see that a new rope is HLO, right? And now what is interesting again here is that I can evaluate and I can relate to the things that might come after a failing assertion without actually having to go there, right? Little things, but they can make a difference. So yeah, so what's interesting also here is, what's interesting here is that the debugger is integrated into the inspection workflow. So there's no end to the conversation that the developer can have. This workflow is available throughout the whole environment. Okay, so another thing that, as I said, is interesting in the environment is search, right? So on the one hand, we have the way we code. On the other hand, we have the way we search for the code. But before we talk about the search, we should just talk a little bit about how the actual interface looks like today. So one of the things that is new in Glamorous Toolkit Beta is the support for native interfaces. So that's really cool, I think. So it kind of looks like this at the moment. That's how the design looks like. This is the home screen. And in that home screen, we have different kinds of, let's say, shortcuts. So we can say, I want a playground. And when I have a playground, then we have a metaphor like in a web browser, where you just basically spawn a new tab for the new context, right? So this inspection context allows us to hold a larger conversation, and now we have a place to store all of these kinds of conversations and then have them separately. Now, a different way to spawn things is to actually do it via the search. So if we click here on the search, right, we can do search anywhere we want, but we can equally just say, I want a new tool. And so now I have a code there that I just opened there. And maybe there I can go and say, I want an object. And then I get the class for that object. Now I can maximize this one. Sometimes it works. But the other thing I can is, so if I go to the coder and I get to an object, right, I can basically get here a different, the preview of the packages, and I can choose a package from there. So this is a different way to navigate through that code. Now, a different way where search is available is basically in the inspector. So let's say here I want to look for a file reference called think, and if I execute that one, it exists. It's a folder. It's right there. Now, because this think object knows how to search itself, because again, the way search is implemented in Spotter is by allowing every object to specify how it can be searched. So because I can do that, now the inspector proposes a new button here, and if I click on that, I can actually go and dive exactly in there. So let's say I'm interested in the tutorial, and I go in there, and then there's the pictures, and I can go and navigate there. So notice how there was no modality throughout this whole interaction. And that's one important principle that we want to follow. We never have strong modality. Throughout the whole interface, we at most have semi-modal things. So for example, in this search, as soon as I click away, it disappears. And the same things we handle with all dialogues. Now what's interesting, and I just want to take a moment to look at that one. Just take a look at how that dialogue looks like, right? It's a beautiful, nice, one single shape that surrounds the whole thing. And it's seamlessly integrated into the interface. That's not a trivial thing. Now, when we talk about Glamorous Toolkit, Glamorous Toolkit is implemented in Faro, right? Who knows that? Excellent, thank you. So it is implemented in Faro, and it is an environment for Faro, but it is not only an environment for Faro. It is an environment for all sorts of languages. In fact, it's an environment for building environments. So what does that mean exactly? There are multiple things that we don't have enough time to cover, such as the ability to analyze systems. So we have integrated all the analysis abilities that a Moose project could do, and it's integrating the same interface. But we also have a new language that is supported right in the same experience, and that new language is called SMAC. So SMAC is the parser, the Smalltalk compiler project that John Brandt created a long time ago. And now this is the very first language that has full support in the environment. Now, what do I mean by a language? Well, a typical SMAC grammar looks like this. So we have a root over here, right? And then we can define those productions in what you would expect in a very large textual description of that grammar. But notice how usually this source is actually in a method in that class of the parser. So we have a parser per class. Every parser is put in a class and it has a source. But out of that source, we generate methods. And now, of course, we can take a look at the methods of Smalltalk, but then they will kind of look like this. And we have no idea what that means. Or me, I don't. And so because my brain is limited, I need a tool. So here's a different way to look at the same thing. Okay, notice how those snippets appear again. So here, this is the same grammar that you saw before, but now you see it in terms of snippets. So let's, for example, quickly just hone on in one of these. So I'm just searching for if statements. And when I open that, I can see that I have the same kinds of things. So I have the things that I have in the source code, but this time I can take a sneak peek of different kinds of productions that I'm embedding in this larger parser, right? So the same idea of snippets is available throughout the environment. The other thing that is available is also the idea of inspection and debuggers. So in this case, for example, we can say, well, I want to test this production. I want to test the if. So maybe I say if x equals 42, then it should return true. And as I do that, right, it tells, oh, now you have a full expression, and before you didn't. And as I move away, right, the debugger tells me, where am I? It's very, very useful for debugging little snippets of code, and then basically refining and refining the parser as you go along. Similarly, there is support for SMAC in the debugger too. But the idea here is it's very interesting, I think, from our perspective, because, like whenever you're in a Smalltalk environment, you always have to think meta. So the idea is that now SMAC is, in fact, so all the completion, all the syntax highlighting, and a lot of the static analysis are actually based on the SMAC as a technology. And now we have SMAC integrated as a language, which basically then allows us to have all sorts of other languages that SMAC already, or that people can develop in SMAC directly being supportable in the environment. So while SMAC might not be an end user programming language, it's a very important piece such that the cost of creating new environments becomes much smaller. And so, right, so here, for example, we see JavaScript, a JS parser that is open on some debugger. So in this case, we are debugging JS parser, parse the same instruction that I had before. And what you notice here is that the debugger allows us to switch the views. So we can maybe maximize that one. And so now we have new kinds of instructions here. So I switched the view on the debugger. So for example, I just want to go throughout each character. I just want to advance one character at a time. And maybe I can see the exact context where I am. So this is the Smalltalk context if I want to, but I can just stay at this level if I want to, and just think of things in terms of SMAC. Of course, this might not necessarily mean a lot for many people, but if you're working with a library, right, you already speak the language of that library. Every library introduces a kind of a language, and usually that language is implicit. And the idea is every one of your API introduces a language, and that language is implicit. Now, of course, we can go and treat this problem as if it's a domain-specific language problem, and it's a very interesting way to take on these kind of problems. But we are saying that that's a very costly approach. If you can do it, by all means, do it. But there is a pragmatic approach to the same issue, and that is the same thing as we had with the baselines, right? There is an ad hoc API. It's very useful for quickly scripting, but we have a cheap way to integrate that API and adapt to that API without having to define a full language and a full formal language for it. So there is a balance between full formalism and what is pragmatic, right? And then in this environment, you can choose. So one of the things that goes largely unnoticed whenever we talk about Glamorous Toolkit is the fact that it actually comes with the whole graphical stack. We started from a complete empty canvas, and we've created a whole graphical stack. And there are a couple of interesting properties in there, and then one of them, or the key property, is that it is always, at all times, everything that you see on the screen is rendered exactly through one single tree. And everything is projected onto that tree. And so what that also means is that we can start to create interfaces that are otherwise, let's say, more difficult to imagine. So for example, here, if I click here, this is a tree, but if I click there, that's actually embeds a full set of widgets there. Now, is this the most interesting kind of visualization? No, but it is interesting enough that we could use this visualization to teach newcomers how the search interface or the search filters diagrams are created. And so search filters compositions are created, and they could extend their own search filters based on for their own domain-specific languages. And again, the interesting thing here is that we can combine, there's no distinction between the visualization and the widgets. Right? They all share the same platform, and so you can intertwine, you can interchange the two worlds. We don't have to confine visual depictions to just a small pane. Now again, the other thing that we introduced last year during the alpha was this idea of live documents. And here's an example of such a live document. And in this case, it's a document describing how real-time hand detection works with TensorFlow and OpenCV, two open source available libraries. So as we go through here, we can see that we have a picture here with a hand up, and there are different ways to look at them. You can, for example, gray it out and maybe try to find thresholds like that. Basically, the goal here is to identify the hand and then count how many fingers the hand has. So this is a different way. So there are different kinds of methods to approach that problem, but in this case, they are susceptible to light. So a different solution here is, this one, a different solution here is to use TensorFlow. And in this case, right, you identify where that hand is, so using neural networks. And so we have, this is the hand, then we can crop the hand, and then based on some image analysis, we apply a little bit of a blur. We can identify where the skin color is. And once we know what the skin color is, then we can actually extract the things. Does anybody see here a cat? Yes, I can't get rid of it. It's always there. So, right, and then all of a sudden, then we can apply, we can look at the contour, and we can identify the different points, because that's the interesting thing. In order to identify how many fingers there are, you basically write a contour, and then you find how many inflection points there are in there, and then you can find the noise in the picture, and eventually you get to 5. Right? So this is an interesting, this is it's basically a live document, because it actually gets computed right as we spoke. So what does it mean? Now, when you read it, right, it looks like a normal document. You can just ship it to anybody and they can just open it and work with it. But this is actually live, and you can edit it live. So as I move the mouse, or as I move the cursor next to the picture, markup appears. The markup is always there, you just don't see it. So it's not a mode, right? It also means that we can go, for example, here, and let's say I delete something, and it tells me I don't have it, right? So the picture disappears. Let's say, and then as I type something, I get completion, and I say enter, and then the picture appears. And what's interesting about this is as I move away with the mouse, the markup disappears, and we can ship this one to normal developers. This has quite large implications on how usable or how welcoming an environment can be to non-technical people, because we think that in order to integrate everything about development, we have to integrate the non-technical perspectives as well. We have to bring them right into our environment. And that's a very important piece. And in order to achieve that, as we said, we did not want to choose between something which is technical or something that is usable. So we created a new category for a notebook. This is in between what you see is what you get, and an edit view. Because all these things happen live. So these pictures get actually injected into the documents through the syntax highlighting. And it all can happen because of this ability of one rendering tree. Now, of course, what's interesting about this is that we can actually go and interact with any of these. So, for example, if I click on the hand, I can go and inspect that. So that's the idea there, right? So we have the same kind of flow happening before. Now, I showed you multiple different kinds of abilities, but again, the point here is that we are creating a new kind of an approach to programming. This is not just a different environment. We think it is a different environment. It's not just a different environment. So the idea here is that you might want to look at it like this. So here we have a camera, and in this camera, right, I could just maybe say like that, and right? So this is an end user kind of potentially end user application. But what's very important, and it makes a big difference to how we relate to our systems, if we bring this environment, right? If we bring this perspective into our own daily lives. So when I move here and I'm in an inspector that just happens to look into something inside there, I want to be able to see it, right? And as I go there and as I see a hand, and maybe I should be able to click on that, and eventually it appears there, and then I can go and debug. And this is so important because in an AI world, errors do not look like exceptions. It is really imperative to be able to look under the hood and understand what the machine did. And this is probably at this very moment in time, is the only environment where you can do that at very, very low cost. So that's what I wanted to talk to you about. I wanted to talk to you about Glamorous Toolkit. And as I said, I showed you multiple kinds of features. But it is not features that I want you to take home with you. I want you to take home this idea that the internal of software systems can be approachable by normal humans. We can make them explainable. And in order to achieve that, we started with that goal in mind, and we created a whole new kind of a development experience. And this is the first time when we actually have a full environment, or the start of a full environment, that people can start to play with. And we would very much like to welcome you to start playing with that, engaging with us. And like if you just look at the features, like we have a new kind of a notebook, a new kind of a live notebook, a new kind of search interface, a new kind of inspection, a new kind of coding experience. Thank you very much.